Hey everyone, this is the IoT talk. So in case you're in the wrong room, we're going to have a lot of fun. I know it's sort of the end of the day, so I'm going to wake all of you up, mostly because I'm jet lagged, and I need to be woken up as well. So we're going to have some fun here. Before we get into it, my name is Danica Fine. I am a developer advocate at Snowflake, where I specialize in open source technologies, mainly Apache Iceberg and Apache Polaris, both of which we will be covering a little bit in this talk. And yeah, so maybe some of you may have seen me on the conference circuit or maybe some of my other talks in the past. I've built a couple IoT talks in the past, okay? So for those of you who have seen me around, you might be asking, oh my goodness, she's doing another one. Yeah, okay, I'm gonna do another one because it's fun. I am relatively new to the world of IoT. And so I get pretty excited when I actually have a use case to build out, because one of my things is that I don't want to make up a problem to then solve with an IoT project. I would like to address a problem that I actually have in my real life. And so I actually have a really good reason this time. A really good one. So how many of you work kind of hybrid at home at some points in your life? Yes, wonderful. We all do. Okay, that's just the reality, especially over the last couple of years. So I work about half the time at home, and my partner also works about half the time at home, annoyingly on the same days. And even though I have my own office in my house, and even though I close the door, and clearly I have something going on in that room at that moment, he will always just come in at the wrong time. And so I need a quiet, distraction-free environment, especially when I'm on calls, when we're on Zoom, right? Or I record a lot of video content. And so I need to be able to indicate to people in my household that I am busy. Please do not come into this room right now. Okay? And so I figured, cool, I can actually build an indicator light, some sort of on-air sign that will tell the other people in my house, hey, don't bother me right now. And on top of that, I figured there's actually a lot of open source technologies that I could pull into this, and so it would just be a fun way to really pull everything into this pipeline. So there's a reason, and also there's a plan. So basically for this, I wanted a way to connect what was going on my computer, right? Camera activity, whether I'm recording something, and Zoom meeting activity. And I wanted to connect that with some sort of indicator light that was powered by my Raspberry Pi. And so ideally, I'm capturing this information from my computer in real time so that it can then power that light in real time, or as close to real time as physically possible. There's a lot of different technologies that we can use to make this connection in real time. But for reasons that might just be completely confusing, I'm going to choose Apache Kafka. I really like it, and we'll get into that. And so I'll feed camera and Zoom events into Kafka topics, and then we'll then consume that on the Raspberry Pi to drive this on-air sign. Now, I know I said that there's a couple of technologies that we could put in as this connector, but the benefit of using Kafka over some other sort of queuing or messaging technologies is really the persistence of the data. I like having that flexibility. I don't want to just throw data in and then use it immediately and have it disappear. I like having the flexibility of doing something else with it later on, which will come up in this talk, believe it or not. And so just because the data that I'm streaming into Kafka right now, is just powering that on-air sign doesn't mean that we can't use it later on for something else. So I would like to consume that data also, do a bit of stream processing with Apache Flink, and then maybe we can do something even more interesting, toss it into longer-term storage in Iceberg tables, and then do more interesting analytics later on. Right, so this is the high-level plan. There's a little bit of hand-waving in here. Most of this is real, though, so we're going to get into it. So this is probably what you came here for, is to actually see the IoT system that I built, okay? Because everybody, for some reason, likes to laugh at me and my soldering skills. So let's build this. So all things considered, I said I've only done a handful of IoT projects in my lifetime, but this one was relatively simple to put together, okay? And I'm going to pretend that all of you are actually here to recreate this, take this all back to your houses and build the exact same thing. So we're going to give you probably too much detail on all this stuff. So first up, most important thing, you need a Raspberry Pi. Sorry. Actually, the component that we're going to use to build out the on-air sign You can do it with an Arduino as well. I am not that person to handhold and tell you how to do that, so you're going to have to read another guide. But if you're going to do it with a Raspberry Pi, great. Follow along. Next up, the most important part, we need an LED matrix. This is going to serve as our on-air sign. It is a bit rudimentary. There were other monitors and things that I could have gotten that felt a little more polished out of the box. But I have plans for this. We're going to 3D print something for it later on. It's going to be great. But this one I got, it's about this big. It's a 64 by 64 matrix. And there's really a lot that you can do with that. So I'm excited that I got this one. And then finally, even though this is kind of a tiny monitor, 64 by 64, that's a lot of individual components to work with all those LEDs. So we need a matrix hat to actually be situated on top of the Raspberry Pi to interface with that individual matrix. And yeah, that's just going to make it a lot more user-friendly when we're actually trying to put things on the matrix. And it also has a component for powering the matrix individually. You can power it through the Raspberry Pi, but it's best to have a backup power source here. So this list, obviously not exhaustive. If you've done anything with IoT before, you know that there are always extra bits and bobbles in the way of cables and connections that you're going to forget about and have to frantically order, or you hope that you have it in the bottom of the drawer when you need it. But most of the things here, actually, most of the cables and connectors that are pictured here did come with the component. I think maybe the power source I had to get separately. But if you're purchasing these components from a retailer like Adafruit or DigiKey, or I'm not really sure what you have available to you in EMEA, but I've seen on a lot of retailers that they have these, easily linked to. For the matrix especially, here are all the things that you need to buy in addition to that. So for this project especially, I didn't have to look too far to actually find all the pieces I need to make this work. So that was good. I think that this is probably a good starter project, or one to dust off the Raspberry Pi for. And so it's a good starter project if you ignore this very critical, very annoying next step, and that is that you do need one bead of solder, one single bead. I tried to avoid it. I thought maybe I could do a little hand waving and not have to do it, but I do actually like breaking out the soldering iron, so it's totally fine. So yeah, there's one critical piece of solder that you need to jump, depending on the size of the matrix that you're using, because there's a 32 by 64 that you can get as well, and there's a different circuit that you have to jump on the back of the hat. And I also ended up soldering a lot of the connections on the hat as well, just to make it a little more robust. And so, that you believe me, really, here's the receipts. Here's my very messy workstation. I didn't bother cleaning up all the other projects that my partner was working on. We just kind of shoved it to the side and took over with the Raspberry Pi. So this is everything post-soldering. I plugged it all in. The Raspberry Pi is behind the matrix there, kind of propping it up. And so what was really cool with the matrix, it has an associated GitHub repository that you then have to load onto the Raspberry Pi with a couple libraries. And so what's fantastic about this, what I loved, is that once you have everything plugged in and you're questioning, inevitably, did I solder everything correctly? And then when you plug it in and it doesn't work and you're wondering, oh my God, was it that or is it the software? Did I do something wrong? This was great because it comes built in with some demos that you can just run with the repository. So you know immediately if this beautiful gradient square shows up and it dances, it spins, it's great. I did not write that. I wish I'd written that. But if it dances, you're good. You did all the connections right, and you don't have to go down that rabbit hole of wondering, is it me? Is it the software? It's probably me, but is it the software? So it was, again, just pretty, outside of the soldering, pretty plug and play. All right. So I had that all set up, and then I needed to install it. This is completely temporary right now because I just renovated my house, and I'm deciding which wall I want to ruin to actually hang this up in my hallway. So we'll see. Follow along. Stand by. It's going to be great. So my goal eventually is obviously to have this out in my hallway or mounted on my office door so that people outside my office know not to come in. For right now, we're completely destroying the illusion here, and it is sitting on my office shelf right behind me in the camera. So I will be thinking, it's my goal when I go home over the next week to actually mount this and figure out where it's going to go more permanently. But for right now, it looks kind of cool, and it's on my bookshelf. There are also books on my bookshelf. I don't just collect adorable things, I promise. So that is where it is for now. It's all plugged in. I had an outlet at the bottom of the bookshelf, so it was like really convenient as far as having a power source. And I figured this was a good place to have it temporarily while I focused on the rest of it. And so with the sign actually plugged in, now I can focus on what data are we actually capturing to power this on-air sign. This is where Apache Kafka is going to come in. So first things first, I've said Kafka a couple times now. I'm not going to pretend that we all know exactly what Kafka is. So we're going to take a step back and level set with y'all. So the high-level description of Kafka, distributed event streaming platform. Okay. So events, in this use case, are camera and meeting information and the status of that. These events are going to be produced to and stored in partitions of Kafka topics, and these events are going to be ordered by their timestamps. So it's effectively just a giant queue of these status events of things happening on my computer. Once they're stored in those topics, then any number of downstream consuming applications can tap into those events and do things with them in a way that's not going to impact other consumers. So that's the big thing about Kafka is, unlike a queue, when we read an event, we're not popping it off and making it disappear. It's there for some configurable amount of time for any number of downstream applications to use. And so Kafka lets us build decoupled pub subsystems that take advantage, and they also allows us to build systems that can take advantage of the fact that we can store data in different partitions, and we can leverage those partitions to parallelize the processing for different applications later on. All right, so we can scale that out for bigger use cases. So Kafka, critically, is a distributed system, so you have to run a Kafka cluster somewhere. And for an at-home use case, this could be run, you can run it in Docker containers. That's completely fine, either on your laptop, or you could run it. I've seen people actually run a Kafka cluster on Raspberry Pis. So if you have like 3 of them in a drawer, I don't know, check the drawer. You might have that. You could run a Kafka cluster at home. That's like on my wish list of things to do. I really want to do that. If you're more hands-off, you can use a service like Confluent or Amazon MSK, or you could just launch it on EC2 or ECS. So you have options. I'm going to do a little hand waving here because you need to decide where you want to run your Kafka cluster. For now, I'm running it on Confluent, but the nice thing about Kafka is that you can just swap out where you're running your cluster, and it's easy. So once you have your Kafka cluster up and running, once I started doing that, I could think about what is the data that I'm actually going to capture here, and what do I want it to look like? So I'm a huge advocate of actually thinking about what your data looks like before you start writing stuff. So I usually start with a schema. And so first we have the camera activity. Hopefully you can read that. So the camera activity is pretty interesting because not only do we want to know if the camera, if is on or off, right? Is the camera on my computer on or off? Am I using it right now? It could also be useful from an analytics standpoint to know what is the application that's using that camera. Is it a Zoom call? Is it Google Meet? Is it Teams? Is it just some other recording software that I'm using right now? I thought it would be interesting to capture that. So I want to be able to accommodate that. So I have the camera timestamp, the status, is it on or off, and then the application ID as well. And then we have our Zoom usage. This is a little simpler. I settled on Zoom usage because like 99% of my meetings happen on Zoom. For the odd other platforms, I was like, whatever, it's a blip for the analytics, it doesn't really matter. So I figured it made sense to make this specifically about tracking Zoom usage. I could make this more generic later on and just have it be like meeting timestamp, meeting status, and then I could capture Google Meet and Teams as well. But for now, we're going to keep it as Zoom. And so for each of these schema, I'm going to create an associated Kafka topic. For these topics, because of my use case and the scale at which this is one computer, I only have so many meetings that I have to go through every day. I hope it doesn't get worse than this. But I only created one topic each for these one partition each for each of these topics. And I set the retention time for them to be about 1 week. All right, so I only need those events to live in that Kafka topic for up to a week. And this is something I have full flexibility to change later on if I decide I need more time or less time. And it really comes down to like if you're paying for a managed service, like how long do you want to keep it there? Okay, so with the Kafka topics created, now I could move on to capturing that data to produce it to those Kafka topics. And so first up, the camera events. I had a lot of fun trying to figure out how to capture camera activity on my computer, especially since not only do I have the built-in camera from the MacBook, I also have an external one that I use for recording content. And so, yeah, I wanted to be able to capture all of this from any camera that I plugged into the computer. It wasn't enough to just track the FaceTime HD or whatever it's called when you select that input. I wanted the solution to pick up anything. And so in the end, I found that I could leverage the built-in Mac OS log stream. Has anybody used that? If you have a Mac, have you used log stream? Yeah, who uses that? What? Anyway, so I found this. You can use it too. So yeah, if you haven't used it before, Macs have a built-in unified logging system. Who knew? And with log stream, you can tap into these kind of just tailing the logs, but for everything. With log stream, you can filter. It has a predicate option, so you can filter for specific contents in those log messages. And then I had to do a little more research, and I found out that the phrase AV capture session is in every log line related to changing your cameras, okay? In case you wanted to know. And so basically, the log stream command that I'm using is the predicate I'm looking for. Is it started? Has it stopped? And yeah, this will just keep spitting out events for me, log lines for me to then parse. Okay, so from there, knowing this works, wonderful. I could easily write a Python script. I could execute the log stream with a subprocess, yeah, and then just wait for all these logs to be pushed to me. Wonderful, it's easy. So then I can extract the relevant information according to that schema, and then we can produce that event to Kafka. Wonderful. I did all the heavy work for you, so now you just need to run this if you want to build it. You're welcome. Now for Zoom events. This is the hacky part, but sometimes hacks are good. So this is a little more involved because I couldn't find an easy, clean way to capture Zoom events, per se, right? So for the camera activity, that is stuff that's just happening. It's being pushed to the logs. It's being pushed to me as it happens. But for Zoom, I couldn't find a way to capture, is this meeting on or off? Right? There were some general Zoom events that I could figure out, like, is Zoom on? But I don't know about you, but I always have Zoom on my computer, so that's not really helpful. Nobody shuts down Zoom when they're done with a call. They're just waiting for the next one. And so what I found was that, as a good proxy, you could check how many ports Zoom currently has open. Okay? So if the result of this is 0, it means that, okay, Zoom could be launched, but okay, we have no meeting open, great. If it's anything but 0, it means we're in a call. Perfect. It's not even a proxy, it's just, is that? Wonderful, is Zoom, are you in a call or not? And so, yeah, so I could similarly take this command and run that within a subprocess and take the output of it and push it to an event in Kafka. Now, this one, I'm trying to make this feel as event-driven as possible because with the camera data, yeah, that's just pushed to me as it happens. But this, I have a 1 second loop. So every second I'm executing this command. And if the Zoom status that I'm extracting is different from the previous Zoom status I extracted, right, then I produce it to Kafka. So it's pseudo event-based. But it averages out over the whole system to being event-based, I promise, okay? So producing that to Kafka. So I have those scripts. I will link to the repository at the end so you can take a look at them. But this next bit, not too glamorous, because we have to make it real. That part's not fun. So I have the scripts that I wrote to monitor the camera status, the Zoom status, but I needed these scripts to be long-living. I've never scheduled something to run on my Mac. Have you? I don't know. Who does that? So I had to figure out how to execute these scripts every time I logged in on my computer. And so this wasn't that bad in the end. So you're going to write a plist file, a properties list file. Has anybody done that? No. Nope. You did that one guy. Okay. No one does this. Anyway, two things to note here. You'll need to set the right permissions on your script, right? So it needs to be executable at this level. And then if you are referencing any files within the script, it needs to be absolute paths. So for me, this was log file and config files as well, okay? So within the plist, I also set the keep alive there. So anytime I log into my computer, it's going to launch this script. Even if the script fails for some reasons or exits, it's going to bring it back up. Okay. So the plist file needs to be saved in the launch agents directory. And then from there, you can use launch control to load it so that it'll then be there for startup. And then for the first time when you're logged into your computer, you should start it. And then from there on, it's always going to be run every time you log in on your profile. And so great. We have those two scripts. Every time I log in, they're running. And then so these are some of the events that we're generating. Something to note here is that I do have a key associated. I'm thinking big with this. I'm like, every computer in my household should be connected to this now, even beyond my work computer. The key here is just specifically for my work Mac. And then I'll also have this set up for my personal so that I can similarly have the on-air sign respond to, when I'm on a regular FaceTime call. Yeah. So cool, the events are being generated, wonderful. So we have that script, it's constantly monitoring my computer, my camera activity, my Zoom activity, producing that to Kafka. Now what we need to do is deal with the script on the Raspberry Pi and powering that on-air sign. So yet another Python script. And within this, we are going to set up two Kafka consumers. I set them up individually, so one will consume from the Zoom activity, one from the camera activity. And so within each iteration of a while loop, I'm going to attempt to consume from each topic, because there might not be new data, but if there is, we want to fetch it. And then we're going to extract the status from that message. I return a Boolean is on if the status of that message warrants the light being on. But I also feed in the previous on value, the Boolean. In this way, if there's no new messages that come in for that iteration, I'm just going to keep the state the same, right? We don't want to reset the light at that point, all right? Yeah, so I have two functions that are doing this, one for the camera, one for the Zoom, and we're extracting both of those. And then from there, I can combine those two Booleans and decide if the light should be on or not. If either of them are true, yeah, we want to have the light on. Missing from the code snippet is a bit of boilerplate code for the LED matrix, setting it up, establishing a canvas, preparing it to display text. So then once I check those Booleans, then I can actually use the graphics.draw text and display either on air if it needs to, or just something, keep it blank or display something fun otherwise. Something to keep in mind with this particular LED matrix is that there's kind of a weird learning curve. It wasn't difficult, it's just a different way to think about displaying things. It's pixel by pixel, right? The Python wrapper for it is pretty decent. It gives you some nice things out of the box. Yeah, cool, I can draw a line. Great, I can add text. But the text that you can write is very limited to 10 fonts that they've preloaded in there, because otherwise it's up to you to figure out all the pixels for it individually. And so, yeah, it was just fun to kind of dig into it and figure out what functionality do I actually have here without killing myself trying to do pixel by pixel updates. All right, takes some getting used to, but it's pretty good. Anyway, so this is what we've got. This is what we've got. It does it. I've achieved the thing that I wanted to achieve, right? So yeah, within about a second of actually updating the status on my computer, like turning on my camera or launching Zoom, it will display on air. Otherwise, we've got hello world. But the fun thing about this, I didn't mention it, some of the wrapper is good for the library, but there is no notion of centering it. And so the amount of time that I spent trying to move things a pixel by pixel on I want this in the center, great. I'm counting pixels for 30 minutes in my room. That was great, but it works. Anyway, so I'm pretty proud of it. It's kind of adorable too. So I'm gonna print a frame for it, a 3D printed frame for it, and before I mount it. So I'm pretty excited for it. Anyway, great. At this point, we have a working model. I'm collecting the camera and Zoom data. I'm sending it to Kafka. We're driving this sign. This is the basics of what I wanted out of this project. But can we do more? The answer is yes, because we have 25 more minutes. Are you ready? Yeah. Okay, so here's a reminder of the plan, now trademarked. So as you know, we've done these bits, right? We have our event-driven pipeline with Kafka in the middle there, but we can make it more interesting. And so if you've dealt with Kafka before, you know that Kafka is great for a lot of things, especially when we want to build an event-driven or reactive system, which we've already done, great. But the reality is that the Zoom events and the camera events that I'm capturing are effectively useless outside of like 2 seconds. You know, like they're just, if for some reason like the Raspberry Pi is down, I'm not going to want that data later for that particular use case, right? We're just going to keep collecting it, but it's like useless for that particular use case at that point. Right, so the TTL for these events is really low. But just because I don't need this data outside of powering this on-air sign as streaming data, doesn't mean that I don't need the data at all or can't use it for other cool things, right? So I'm going to take these events out of Kafka, do a little bit of stream processing and offboard them to a system that can help to aggregate that data in the long term. And then I could do some fun analytics on top of my data that I'm bothering to capture anyway. We're going to do this using Apache Iceberg tables, right? So the whole goal here is analytics. That sounds very much less glamorous than the initial plan of like building a cool IoT system, but I promise it's exciting. Because you might be asking yourself why we're bothering with analytics when this talk could be cooler in a different direction. But that's a great question, but I'm going to answer it with another question. How many of you use Google Calendar? Yeah, you all do. Are you familiar with that fun, very stressful little feature called Time Insights, where they tell you how long you've spent in meetings over the past week or month? And where has your life gone? What is your life? Do you see? I got a new job in November. Do you see how it's just gotten worse? Anyway, I love my meetings. But I see this, and I'm constantly reminded of how much time I spend in meetings. And I'm like, wouldn't it be fun to recreate that with this data I'm already capturing? Yes, the answer is yes. It would be very fun. All right, very fun. Yeah, so since I'm already spending time capturing how long I'm on calls, and sometimes I'm just on Zoom without scheduling a meeting, right? So this is going to be a more accurate representation of how I'm spending my time. Plus, I have the added dimension of this camera data, right? I don't just spend time on Zoom calls. Sometimes I'm using my camera to record content, right? And so I have an added dimension here of things that I could look into when I want to, when I'm looking into the analytics here. So the goal here is to offboard the data from Kafka so that we can do analytics like this in the future. Okay, so as I said before, Iceberg is what we're going to be using for this part, or what the goal is, right? Moving it into Iceberg tables. So let's take a look at what it is, because how many of you have heard of Iceberg? How many of you are using Iceberg? None of you. This is a blank canvas. This is beautiful. You're all going to leave Iceberg users. Great. So Apache Iceberg, it is an open table format. You may have heard of it recently. It's been making waves in the data engineering community. No? Join a new community. You're going to love it. So Iceberg, it's an open table format. It was purpose-built to handle large-scale data sets in a data lake. Okay, because that's all the rage now. You just throw all your data in a data lake. Yeah? And so Apache Iceberg, it is not a database in and of itself. It's not trying to be. It is a specification for how you should organize your files in object storage to better coordinate for, at read time, right, when you want to access that data more efficiently and update those data sets. So it does this by adding an extra layer of metadata on top of the files that you would want to be storing anyway in your data lake. So when you think about it, Iceberg, or what we get out of it, is kind of the love child of data lakes and data warehouses. We get the convenience and flexibility that we get from a data lake, where you get to throw whatever type of data you want in there, but you get the structure of a data warehouse, right? You can query these Iceberg tables like you would any other table in a data warehouse, but you get the benefit of a data lake, right? So it's a good thing, all right? So Iceberg is great because we can write our data once, And it handles all the data formats that we want, Parquet, Avro, Orc, and then we can use whatever tools we want in the Iceberg ecosystem to then query that data or update that table. So you can interact with it from all these different engines. And to really drive this home, Iceberg is, I think, a really great add-on to event-based, Kafka architectures because it gives you a cheaper way to offboard this data, right? To use it for fast and more efficient analytics later on, and it integrates pretty nicely with real-time pipelines. So, quick aside on Iceberg's sort of architecture, because this whole hand-wavy metadata layer is very hard to visualize on how it does this. So Iceberg is effectively its metadata, right? We're adding a couple metadata files on top of our data files to then coordinate it. So we have manifest files, which track subsets of data files, and it keeps track of statistics on the bounds of data in the columns that are stored in those data files. And the purpose of that is so that we can query more efficiently. Right? We're not going to open a file. We're not going to waste time fetching that file from object storage if we don't need it. Okay, so it makes it more efficient. Manifest list, the manifest file statistics kind of roll up into the manifest list, and so they're going to track all the data from a given snapshot, and then we have our metadata file, which knows about all the snapshots we have in our table as it's evolved, and that's kind of like the entry point into our metadata here. But that's not all. There's one more critical component to help Iceberg tables behave more like regular database tables, and that's the catalog. And so the catalog keeps track of the individual tables and a reference to that metadata file, that main point of entry, so that we can actually query our tables effectively. And then it also provides ACID transactions and guarantees as we have multiple engines trying to interact with our Iceberg tables at once. Right. There's a lot of different catalogs out there, but the reason I went into this is that we're going to use a catalog called Apache Polaris when we actually work with our Iceberg tables here. All right. So those were sort of the high-level components of Iceberg, the metadata layer, the catalog layer, but we know that Iceberg is just a format. It's just telling us how to build those files up. Iceberg is not a database, so it doesn't mean it stops there, though. So the great thing about Iceberg is, like I said, that we have a ton of tools and compute engines in the ecosystem that you can use to generate those files, to make Iceberg tables and interact with them. And so that means that and they're fully interoperable with one another. So you can use different styles of engines for different use cases and access that same copy of Iceberg data. Okay. So conveniently, the Apache Iceberg project ships with a couple of implementations of compute engines. They have built-in support for Apache Flink, Apache Spark, which are great for getting started quickly. But beyond that, the Iceberg ecosystem is growing. It's very healthy. And so there's a number of other query engines. This is not an exhaustive list. There's a number of other query engines and tools available to you to work with your Iceberg tables. And you don't have to pick one. Like, you can use all of them at once, and that's completely fine. Because most of these tools, even the vendors, are supporting, just show us where your Iceberg tables are, and we're going to access them for you and let you query them. So hopefully we're all at least moderately convinced that Iceberg would be a good next step for open source analytics. Yes, so especially considering our long-term goals here. So now that you already saw a glimpse of how we're going to do this, but for completion, I want to let you know how you can actually get from Kafka to Iceberg, because you do have options. Okay, so basically you're choosing between Spark, Flink, and Kafka Connect. Okay, so which you would choose for your real life situation, your production workload, is going to depend on a couple different things. Namely, is your team actually using any of these tools already? Because you don't want to have to relearn something entirely. What your SLAs are, because each of these have configurable SLAs, different bounds depending on what you're trying to get to, and what Iceberg features you actually need on the Iceberg side of things, because there are some limitations on each of these. But we are going to be using Apache Flink. I know I didn't hide it from you in the beginning. And have you all heard of Flink before? A little bit. Some of you said no, so we're going to have to do this. Okay, so pretty straightforward. Flink is a distributed processing framework. And while it is flexible to do both batch and stream processing use cases, it's really, really good at Kafka. I think the Kafka Flink source and the Kafka Flink syncs are probably the most used connectors in Flink to move data in and out of the framework. And so that's why I wanted to use it here with Kafka. And it's also already maintained as an implementation by Iceberg, so it just made sense to use that. Right. Flink also has different levels of APIs depending on your particular needs and use cases. And so one of those APIs is SQL, which is what I'll be using both to read the data from Kafka and write that data to Iceberg tables for us. And in my opinion, FlinkSQL is just an easier way to get started with it. So we will spin up a FlinkSQL client. And so reading our camera activity topic is as simple as creating a table with a Kafka source. So you see here, we have that connector property on line 8, connector Kafka. That is enough to specify we're using that. Then you want to refer to the specific Kafka topic on line 9. And then from there, there's a number of just basic consumer configurations that you'll need for any consumer application, group ID, the brokers where you access that, schema registry, and a couple more authenticating pieces. Okay? But from there, we define a table much like we would in any database. Right? You define the fields and their types. And one other thing I wanted to call out, which is pretty cool in Flink that you can do, is that on line 6, we're doing a derived field. As we're bringing this data in from the Kafka topic, we're doing a quick bit of processing to derive an additional field on top of one of the fields that we're bringing in. And so here, I'm just extracting just the day of the timestamp, right? I want like, April 1st, 2025. And we're going to use this for the purposes of partitioning our data in the Iceberg topic, Iceberg table later on. Okay. And a reason I wanted to call this out is that partitioning in Iceberg is really important, and it's a best practice to partition your data. And really, it's about, we want to minimize the amount of file I/O that we're going through, and any way that you can partition your data better on Iceberg is going to be beneficial to your reads and your reads later on. Okay. And we're going to do something similar for the zoom activity. We're going to bring in that partition timestamp as well, connector Kafka, and then we're pointing to that zoom activity topic. All right, so at this point, that's all you have to execute within the Flink client to access that data. And because it's a Kafka consumer, all of this data, every time you query it, is just going to be pushed to you. All right, so you have access to that entire topic within a table sort of SQL format. And so, we've loaded everything in there. But now we have to prepare Flink to connect with S3, to write our Iceberg tables, and so on. And so what that begins with is by defining, or in this case, connecting to a catalog, right? Remember, a catalog is a critical component of working with Iceberg tables. And so specifically, they're going to help to maintain those ACID guarantees and some semblance of organization as we throw this data into our data lakes, okay? So we really can't function without the catalog. So outside of this Flink client, I'm running Polaris. Locally for now, that's a task for next week to productionalize that. So within Polaris, I have established a catalog. I've created a number of roles, of privileges. I've assigned those to myself. I've given myself an account with it. And along with that, I've created some credentials that I can use to authenticate myself from the Flink side of things. And so by running this statement, I'm giving Flink access to that catalog. I'm allowing myself to create tables within that catalog. And in doing so, those tables are then going to be pushed to as Iceberg tables on S3 for me. Okay, so it's a separate catalog within the Flink SQL client, but then it's going to write everything on the back end to S3. Okay. And so from there, we need to create the camera activity and zoom activity tables within this catalog. Okay, and note that I'm partitioning by that partition timestamp, but otherwise I'm creating it's like the same create table statement just within this catalog. All right. And then to populate the Iceberg tables, we do just a select star on that camera activity, that zoom activity topic, and we're inserting into those new tables that we created. right? And so note that this is just one instance of me running a SQL client and running this task once, but you can imagine this being a scheduled task that I run every couple days or at the end of the week to offboard all of this data from Kafka into Iceberg for me. All right, and the result of running this, so within S3, we actually have these, you can see all the data is going to be within the different partition folders here, and the data is stored as Parquet on the back end for me to access, right? So that's the part that you need to know about. So we have about 10 minutes. And I know this isn't, I need to remind myself to start closing out, otherwise we're gonna keep going. And I know this is like not as glamorous of a way to end as I would like to, but I want to leave you all wanting a bit more, okay? And so I promise it'll be exciting. But at this point, you know, the data is in Iceberg tables on S3. And at this point, I could use any Iceberg compatible compute engine to read that data and do whatever I want with it to my heart's desire. And I'm not sure if you all noticed, but I only have about a week of data right now because I literally just built this thing. There's nothing like a deadline to motivate you to build something. I encourage you all to give conference talks about your IoT projects. It's very motivating. And so, yeah, I only have about a week of this data that I've been collecting for in an Iceberg. So any analysis that I would do right now isn't going to be that interesting. So instead of doing that, you know, I am excited to have it run further and do that part of it. But instead of doing that, I would like to introduce you to my backlog of things that I want to do with this and will be doing over the next couple weeks, the next month. And I hope that you'll follow along. I will link to the repository. But I am very genuinely excited to take this project further and do more stuff with it. So first up, make it all real, really real. Right now, the bulk of these stages with Flink, with Polaris, are being executed on my computer, on my laptop. So within the next week, I'd like to run Polaris somewhere more permanent, probably through Amazon. And also along those lines, I want to figure out the right interval that I should be syncing the data out of Kafka. I probably don't even need that event data to be in there much longer than a day or two, really. So if I can execute that at the end of every day and being able to schedule that, again, more formally, probably through EC2 or ECS. So from there, the biggest thing that I'm excited for is to actually do the analysis on this. Unfortunately, we do need more than a week to do anything interesting. And so this will probably be one-off analyses for a little bit until I settle on exactly what I want to look into. But I could envision sending out, if you have an iPhone, you get that like weekly report of your usage on like Sundays, and I'm always just sad to see how much time I spend on my phone. But I envision sending out a push notification like that, like, hey, this is how much time you spent recording and on meetings, and didn't you have a great week? Yeah, of course I did. And so, yeah, I'm just excited to play around with, also use this as an opportunity to play around with different Iceberg-compatible compute engines, because you know, there's dozens out there, and being able to access my Iceberg tables wherever, it's just a good opportunity to play around with different ones and see what's easiest to use. So as far as this component actually goes, I envision there being like two main parts here. The first is to take advantage of Flink a little bit more, lean into it as more of a stream processing tool. I want to do more pre-processing of the data. Specifically, I want to align the Zoom and camera data into one single topic so that then we have sort of the overlap. So if I am on my, on a Zoom call and my camera's on, great, that's just a meeting. But I want to look at like, when am I on Zoom without my camera on? Was it a bad day? Or did I just roll out of bed? Probably. And then also being able to look at, when I'm just on, recording content and not on a call, right? So being able to, align the two topics. So I'm currently playing around with that query. And then within the query engine, on like the Iceberg side of things, I want to compute the time intervals, the time spent on calls, the time spent recording, time spent with camera on and off and whatever. And yeah, so these are sort of the basics that I must have in order to definition of done. Almost there. Now for the stretch goals, because they're much more fun. So when my partner and I are both working from home, his workspace is in the garage, which is all the way across the house. That is too far for him to be coming in to come check the status of the on-air light. And so I figure I could create a chat bot that, because when I'm on a call, when I'm doing something important, I'm not going to text him back and say, hey, I'm busy. No. So I want the chat bot to do that. All right, so that he can message the Danica bot and get a response. Am I busy? Please don't come into my room right now. I'm busy. So I think that'll just be fun. He'll never see it coming. I'm excited. And I also, finally, it's not just using, being on Zoom calls or using my computer. Sometimes we just need, to focus. Right? And so I would like to be able to trigger the on-air sign for other things. And so this will be another IoT project in and of itself, but I would like to build a desktop set of buttons. So focus time, okay? I'm deep thinking right now, don't bother me. I'm on a phone call, maybe. And then I'm also thinking that when I'm recording content on my phone, to also. So that way I have separate applications that I could then capture those events for and factor that into the analysis. So I hope this gets you excited for what's to come, because I'm very excited for this backlog. And if you have any ideas for other things that I can add, please tell me. And I'm saying that so that I hope also that you'll all follow me as this project evolves over time, because it's going to be a great summer. So I am running low on time now. It is now blinking. That's wonderful. So to really bring us home here, I'm going to remind you of the original plan. Okay, so remember what I set out to do, and that was create a real-time pipeline that connects events on my computer to the Raspberry Pi. We then used a separate workflow to consume that event data with FlinkSQL, created a Polaris catalog, and wrote that data to longer-living Iceberg tables. And I think that's pretty cool. You sat through the whole talk, so I'm thinking that you also thought it was really cool. But this is more than that. If you squint a little, and kind of forget the fact that you are here for an IoT talk and just for a fun use case, this is actually an interesting pipeline to be aware of, okay, professionally. You can take this to work. Think about it. I built the real-time component to be as robust as possible. With Kafka in there, we can easily scale out to more producers, more consuming applications for different use cases there. And you can always scale that out for production capacity. Kafka is easy like that. And even if you, or say, your company is already looking at Kafka for real time, I'll bet you also have plenty of analytics use cases. They're never going away, okay? And so it's not all Kafka all the time. And so being able to extract that data from Kafka, do some stream processing, and offboard it to areas where your analysts can actually make sense of it and use it more effectively, that's a very real use case, and that's something that's coming up more and more over the last couple of years. So it's useful to be aware of how these components actually connect to one another. And so while I hope you enjoyed this session and my story of building out this project for fun, I hope that you'll actually take this and maybe apply some of it to your own work, both personally, professionally, and maybe you'll consider using Kafka or Flink or Polaris or Iceberg at some point in the future. And with that, here is a link to my link tree. I promise there's a link in there to the GitHub repository if you want to see the receipts and take a look and follow along. And also some other interesting resources there as well. But yeah, thank you for coming. I hope you had a good time. And I think I have time for one question, but I'll be around. There's also stickers for all 4 of the technologies we talked about today. So make sure you get those. Thanks. Let's see, question?
I'm by no means a Raspberry Pi expert. Is this scoped to your local network, or do you flash on if you open the camera at work in the office?
It is not at all tied to the local network.
Okay.
No, because my computer is writing to, I'm using Confluent for my Kafka cluster right now, and so that is off in the ether.
So yeah. Do you plan to make it location aware?
Add it to the backlog.
Okay.
I could. I didn't have plans for that, but maybe I should.
It's essential for the Home Assistant integration. So you can lower the lighting when you're on a call.
I must do it. Yeah. You're right. Dang it. I do, however, have my Raspberry Pi on a smart outlet, so it's only on when I'm home. So we're good on that. Maybe I don't have to do it then. Nice. It's done. Yes? Someone has the mic. Yeah.
How much do you spend on cloud resources a month? And how much do you plan to spend on cloud resources a month?
That's so fun. I hope my boss doesn't watch this. So also in the backlog is to move off of, I'm using some trial accounts right now, and to move that off, especially for the Kafka cluster. But for S3, I haven't actually looked into it. I could, but we just kind of have an account at work that everybody just pretends we don't pay for. Yeah, but I can actually get those numbers for you. Take a look. This is the benefit of building these things when you're employed. Yeah. Yeah.
I see 2 hands. Do we have time for 2 more questions? Can we do that?
Keep going. They're not forcing us out.
I was wondering, how does this stack that you have now compare to a solution with PostgreSQL? Why would you go this route instead of filling up a table with PostgreSQL?
Yeah, it's mostly to explore more of the real-time components of it. So especially for the envisioning the chat bot that I would have and being able to have push notifications. I just I like having the information pushed rather than a polling model. And so, yeah. And also I think, no, you can challenge me. You can do it. Yeah, and I think also as far as obviously there are architectures out in production that have nothing to do with these components. But I think that this is a very popular set of technologies that are being used together now. And so I always think it's fun. Again, I'm building something that's kind of a toy use case at home, but I think it's always fun to challenge yourself to build something as though it could be productionalized. And so just getting familiar with those tools is kind of fun too. So yeah, thank you all. Please take some of the stickers. They weigh so much. I don't want to take them home. So thank you all.